Hi folks, Mr. Long here, doing another screencast for test solutions, and specifically mastery questions that you may want to redo. So this is one of those questions where I actually gave you the derivative and then you had to do the simplification. So you had to demonstrate that you could simplify this. And the whole purpose of simplifying something like this is to be able to find out where the critical values are. So in other words, being able to set f prime of x equal to 0 and see where there might be minimums or maximums for this function. And specifically, that's the focus. So let's take a look at this. And here are some things I want you to notice. So this question would have been created through the use of the product rule. So there's some things, some patterns that you're going to notice. So if this is x cubed, I automatically know this is going to have to be x squared because remember it's f prime g plus f g prime. So in other words, if that's g is x cubed, then g prime is going to be x squared. Makes sense, right? Similarly, if it's f prime g here, then that means that this here, or actually let's write this down. So this part here would be, that would be probably f prime there. Okay, that would be g. This right here would be g prime, like something like that. And this would be f. Okay, so um, g doesn't look like a very good g, does it? Oh well, that's fine. So if you look at that, and again, I'm not worried if when you go to redo this, if you are redoing it, I'm not concerned about the coefficients as much as I am the exponents. So let's think about that for a second again. F prime is in this right here, so that would make something like this. So if this is an exponent 1/2, this is going to be exponent -1/2. It's the exponent is 1 less. Similarly, if that's g and that's g prime, the exponent is 1 less. Okay, so again, you can do it to however you'd like to do it. You could do it with 1/3, and then you'd end up with -2/3 in your other exponent, or 2/3 and you'd end up with -1/3. You could use exponents 6 and 5, but you've got to get that order correct. Okay, so again, it's the product rule we're dealing with here, and one of them has to have a radical. Okay, so let's look at this now. First thing I'm going to do is represent these square roots with rational exponents, which you're quite familiar with from all the way back in grade 11. So this is division, 6x plus 5 square root, so it's going to be a negative exponent for sure, and then the square root indicates 1/2. And so it's x cubed times that. And then this one's much easier because it's 3x squared. And then we don't need a negative exponent here because it's just positive square root. Okay, so 1/2. And so let's take a look at this. Let's see if we can notice what are the common factors. Okay, greatest common factor. Well, the thing is, if we're to do the greatest common factor, it's a kind of it's misleading term. Greatest common factor actually means the factor with the smallest exponent. So if x cubed and x squared, the greatest common factor is that x squared. Similarly, because 2 is less than 3, x squared goes into x cubed. X squared is a factor of x cubed, right? That's why it's the greatest common factor. So what about the 6x plus 5? What's the greatest common factor? Well, it's always the thing with, if the base is the same, it's the thing with the lowest exponent. So in fact, it's this right here. That's the key right there. That's your common factor. Okay, so we've identified our common factors and we pull those to the front. So we've pulled those to the front. Those are our two common factors. Now what I need to do is divide. So I'm going to have x cubed divided by x squared, which gives us x. And I've got 6x to the plus 5 to the -1/2 divided by the same thing. Something divided by itself is always 1. So then I've got a plus sign here, which gives me a plus sign here. And now I have 3x squared divided by x squared. That's what factoring is, right? We're dividing that out. Well, that's just going to be plus 3. And then what's going to be left? Ooh, this is a tricky one. I've got 6x plus 5 to the 1/2 divided by 6x plus 5 to the negative 1/2. And let's think about that for a second. If we're dividing, we're subtracting exponents. So I've actually got 1/2 subtract negative 1/2. And that, I think we know, 1/2 subtract negative 1/2 is 1/2 plus 1/2, which is 1. So I'm just going to have 6x plus 5 in a set of brackets. Okay, so we have that right there. And now what I need to do is simply to expand it out. So I've got 3 times 6x, that's 18. 3 times 6 is 18, 18x. Plus that little x there makes for 19x's. Then I've got 3 times 5. This is what a lot of you missed, by the way, is the 3 times 5 here. You just put a 5. But 3 times 5 is 15, right there. And then finally, we're not going to put anything back with rational exponents. We want to put things back into radicals. Negative exponent means division. That's why it appears in the bottom. And it's exponent 1/2, which is square root. So this is fully simplified, and you could easily determine by setting that equal to 0, that would give you one of the critical values, as would x squared equals 0. So now you'd be able to find where there's minimums or maximums by setting that first derivative equal to 0.